Okay, so it's a little late start here, 5:23, so we're got to go to 6:23. All right. Hello, everyone, and welcome to Handmade Hero, the code where we code a complete game live on stream. We are now in the position to start playing with like some UI stuff. A lot of people have asked about UI stuff before, probably because of my reputation for I am GUI things. We get that question a lot. And honestly, Handmade Hero is not really a game that involves any kind of UI in that sense. There's no buttons or widgets in the gameplay for Handmade Hero. You are in direct control of a character. And so there really isn't any particular reason why we would be implementing any real sorts of UI in this game. But since we do have debug code in the game now, and we do want to be able to use that debug code effectively, that tends to be something where UI wants to be available to the game, right? And so what we're trying to do in this circumstance is we're trying to make user interface like UI code, right, whose goal is very specific. Normally, if you're trying to make end user facing UI code, what you're trying to do is make it be as usable as possible for the customer, right? For whoever you're shipping this to, whatever that is, right? If it's a game, then the player. If it's some business software, then whatever, right? The person who's buying that thing. But in the situation for UI in this case, what we're actually concerned about, since we're the only people using the UI, we're only really concerned about two things. Can we use it quickly enough to make it be usable for the purpose that we need it for? And since we wrote it, we know exactly how to use it. It doesn't need to be discoverable. It doesn't need to be easy to use. It just needs to be efficient enough that we can use it. And then the other thing, and the most important thing, is that it should be extremely low implementation cost. Because we don't want to be spending a ton of our programming time building UI or fussing with UI that nobody's ever going to see except us. We don't care how janky it is because we're the only people who are going to see it. So any time that we spent making the UI like prettier or fancier or more functional or any of that sort of stuff is probably wasted. We have to have some kind of a good case for spending any time on it. So what we want to do is try to figure out like essentially the highest leverage way of implementing the UI in any particular case. What is the way that we can write the minimal amount of code into the game and get the highest number of debug UI features out of it, right? That is what we're trying to do. So with that in mind, you've kind of already seen me sketch out a little bit of that. We implemented some stuff last week, just a little light stuff, like being able to hover over things to see what they were doing, and also to be able to like click on things to like drill down into them. And I don't know if you noticed, but of course when I implemented those, I didn't do anything unusual. I didn't create some giant UI hierarchy. I didn't go Qt on it and have 800,000 classes just to implement a button. All I did was I put an if statement into the code that said, if you are hovering over this rectangle right now, and it becomes the like hot rectangle, and if you click the button, then it executes some action on that rectangle, right? That's all I did. And that is the attitude that I think you want to take for making debug UI in a game. You want to make the thing that is the easiest to implement, that doesn't cost you any time, that doesn't lead to like code rot or anything, that just is nice and tightly bundled with the actual output code, so that the rendering and the UI line up nicely, and so that you can expand on how you're rendering things and trivially have the UI kind of follow along with it. All of that sort of stuff is really what you should be shooting for. And that is exactly how we are going to continue progressing down sort of that path of implementing this debug UI up to the point where we feel like it's good enough for us to use on the project. So we're going to take a slight step back from what we were working on last week because like I kind of just shoved some things in at the end because it was kind of wrapping up the week. We're going to take a slight step back, and what we're going to do first is say, all right, we need a little bit of debug UI here. the very first and most obvious thing that we should probably do before we go any further is have a way of turning this profile view on and off, right? Because right now, if I go run the game, right, let me just bring it up here. We now have profile bars all over everything, and we were playing around with those, and that was all fine. But the problem with that is that we can't see the game, right? So at the very least, we are going to obviously need some way of saying whether we want to draw any of this stuff or not. Because if we are in a situation where we're working on the game and don't really care very much about seeing profiling in detail or any of that stuff, then either A, we want the profiling to go away completely, like just gone, or, we also probably would want to consider something like a collapsed view that's just a very small, sort of extremely small debug monitoring version that just sits in the corner and is designed to only draw whatever is necessary to alert us to a potential problem that we might have missed. So for example, frame spikes or things like that, just show the total amount of time for the frame retirement maybe goes in there, so we can say, oh wait, we saw something weird happening there, so that we can go grab it, right? Something like that. So that to me is more what we want to focus on. So I want to start putting in a more solid concept of the debug rendering stuff so that we can get to the point where something like that is nice and achievable, and we have a solid story for how adding things to that UI kind of like comes in. And you'll notice up to this point in Handmade Hero, when we had debugging features and things like that we wanted to implement, you'll notice we also kind of had this problem of they just kind of always had to be shoehorned in there, and we never really had a good way of like turning views on and off. Now, that may not be such a big deal, actually, if you think about the fact that we have live code editing ability, but there is a problem, there is a shortcoming with live code editing ability. While live code editing ability does totally solve our problems in terms of like tuning a particular piece of code, because we're working on that particular piece of code at that particular time, and it all makes sense, live code editing doesn't help us if we have a number of different debug, like visualization kind of things that we might want to turn on and off. For example, if we want to draw like entity bounding boxes, right? Yes, I could make that be just a live code editing thing where I just go back into the code, right? I change the entity bounding box thing, and then I come back. That's a totally valid way to do that. But that's a lot slower and less convenient than if we just knew we had a list of things we could turn on where we could just quickly go click on them and say, I want entity bounding boxes on right now, right? So there's this concept of like collating that stuff into one place. And so there's a couple different ways we could do that. But at the very least, even if we decide we don't necessarily want debug UI for it, if we want to have it so that it still goes through the live code editing, then what I think we would want to do is at the very least make a file that's got all of those debug switches in there in some kind of like way that's easier to deal with, right? So that they can all be kind of seen and touched quickly. You know what I mean? So I feel like that's just kind of a, an obvious sort of adjunct thing that we want to do. So let's start working on that. Again, I don't have anything in particular in mind. I'm just going to go ahead and start doing some code transformations that I think will get us there, because I know roughly I need some buttons or something. I need some way of starting to interact with this thing. So let me just open up Handmade Debug. Again, as I should mention, it's day 190. So if you did a pre-order on handmadehero.org, you want to follow along at home, day 189 source code is the source code that I'm starting with here on day 190. So unpack that into a directory if you want to be lined up with us. All right, so in Handmade Debug, first thing I want to do, and I said I wanted to do this originally, is I want to get rid of these global variables here because we just kind of threw them in there when we were kind of working with it before. We already have the concept of debug state now. We really don't need these global variables for anything. So I feel like now would be probably a good time to sort of clear that out, right? To sort of stop dealing with any of those global variables, because we did the work already to have debug state that's stored. So I'm going to go ahead and get rid of those. And also, if I remember correctly, I feel like the fact that we were using those global variables also meant that our loop live code editing would break the debug system, right? I don't really remember if this is true, but I feel like it should have been true because the global variables would not get reset properly. I don't actually know if that's the case, but here I'm going to recompile. Yeah. So when I recompile, right, the debug system gets hosed, right? And so that's not a good thing. So again, that's another reason we want to do it, even if just not to just get the things out of the global scope, so we just don't have these names floating around in the global scope for no reason. But besides that, it's just pretty easy for us to do. So the first thing I'm going to do is I'm just going to go ahead and move these guys in here, and go ahead and do a kill rect on that, and then move it over. Okay, so now I've got these guys in here. And now what I have to do is come through here and make sure that everyone who uses that stuff, which is all going to be a compile error, is now going to have some kind of a ability to call through the debug state. Now I guess I have a problem, which is that the font ID defines are not above this guy, so they can't actually be used. I'm not sure what the most effective way is to deal with that, but I assume that that is in the file format stuff, and the file format stuff doesn't have any code in it, so it's pretty free, I think, for me probably to put it up there. So now in here what we need to do is we need to make sure that we can get at the debug state. So I'm going to go ahead and grab that out. There we go. There's that debug state. I don't remember what I called that down in these other things. Do I call that debug state typically? I do. So I'm just going to call it debug state here as well. And debug state now just kind of needs to store this sort of stuff. We don't really need to call it global anymore, but I'll keep calling it that for the temporary time being, just when I'm doing this port. And then we can decide if we want to change the names of some of those things in the future, right? So I'm going to go ahead and change these guys here. Debug render group, I'm not sure where that's coming from. That must be defined elsewhere, so we should also probably make that be something that pulls inside as well. So we'll handle that in a second. So there's that left edge. There's the font ID. There's that font scale. So I think most of that is probably okay. Let's let the compiler guide us through the rest of this here. Okay, so debug text out at. Let's see. So I feel like in general the debug state probably doesn't want, I feel like the debug state pointer is probably the one thing that we're going to want to be global there, right? Because what happens here is the debug state global is really just the game memory global. You know, if you have the game memory global, then you know what it is. And so every time on entry into anything, as long as we make sure that that gets set, right? When we do debug global memory equals memory, this stuff right here, having debug global memory is all we really need in order to make sure this stuff gets processed correctly all the time. So probably what I want to do instead of having this passed in, now that I think about it, right, is I probably want to do something where I always just get from the debug global memory, I always just get the debug state out of that, right? So I always just have a thing here which is like, you know, get debug state, you know, or debug get state, something like that. And then that function is just a known inline that doesn't take anything and uses that debug global memory there to get the debug state. So what this would essentially do is just say, okay, as we saw down here, right? Oops, that's the wrong place. Where is it? Where is it? Here it is. As we saw down here, right, if we know what the game memory is, then we know what the debug storage is. So it's always pretty free for us to just say, anybody who wants to can get it like this, and we have the debug global memory, and so we can access it off of that, right? And that will always give us that debug storage. So that is the easy way to make sure that that always works, and then we only have to make sure that one global variable is updated on entry into the game system, which is pretty easy to ensure. And then we know that everything else will work as long as that's the case. And then everybody else should probably do an if on it. So if it's running without debug services, it just won't do anything, right? And that'll be fine. So I think that's sufficient. At least I assume it should be. And I think that's all we really need. Now the debug render group, I feel like the debug render group should also be something that's actually just done a little more directly, I'm not sure where that's actually getting defined. I don't remember where we put that. It's been a while, so it's right here. So I feel like that is something that we want to just go ahead and pull inside as well. So I'm going to go ahead and finish this stuff, but then I want to make sure that we address that other one as well, because I want everything to go through a single sort of uniform path that looks like this everywhere, always, right? So I really want it to be like that, and then instead of having an if debug render group, we'll just get rid of that, and we assume that once we get the debug state, we have the render group, if that makes sense. Okay, so if we have the debug state, now we should be able to get all the rest of the variables. Debug state font ID, font ID, font scale, font scale. Same thing here. There we go. Again, I'm not really doing anything other than just moving these global variables into things that are referenced directly so that we know that it's all kosher. There we go. Let's see, push font. Again, same thing here. We've already got in the debug overlay, we already have this information, so you don't actually have to query it. Although it does mean that debug overlay doesn't actually need to take game memory for any particular reason, actually. What we can do instead is just do this, and then we know that that's just going to use the exact same path that everybody else does. And I like that a little bit better. So we'd just do this, and then we'd do it this way. Okay. So that seems fine. And debug state left edge, there we go. And debug state global height. Okay. Debug overlay, the function, yes, that's true. Debug overlay does not take that anymore. Thank you for mentioning it. That is just this now. And now we're done. Okay, so I think we should be in reasonable shape here. And so, yeah, nothing has been altered at all. So now we're just operating without the global variables. I don't actually think, however, that we have fixed the problem quite yet, because if I was to recompile, the debug render group will go away, right? So that's why I say we also want to fix that one. So even though we moved the rest of those variables in, those were not really the entirety of the problem. We need to make sure that we don't use any more global variables so that we don't have any conflicts with that. So that's okay. This stuff is totally fine here. All we really need to do, and we can get rid of that to do as well, is make sure that our debug state stores that stuff as well. So we have a render group in here, and we'll call, that we'll use. And we'll just make sure that that gets initialized in some kind of reasonable way. And so I'll pre-declare these guys, since we actually use them in the debug system. And then we'll go through here and try to figure out what the best way is to organize this so that we know that it gets initialized properly and so on. So you can see in here, inside the render group allocation and everything else, we allocate stuff out of the transient arena for the debug render group. That doesn't really make a whole lot of sense. It's not a particularly useful thing to do, I don't think. So at the end of the day, I would rather not do that. I'd rather have that pull out of the debug memory itself. And so in order to do that, I think we want to move this out. And we need to get the asset information in, but I believe that debug reset actually does that, right? It gets past the game assets already. So what I think we should probably do is just move this out entirely and do that allocation in the debug reset. And the debug reset will just, if there isn't one yet, it'll just make sure that it does it at that time. So inside debug reset, we have the information that we need. So in here, I feel like we could do something where we just say, okay, if the debug state render group does not exist, we'll just create it at that time using the resources that we have. You know what I mean? Because we know that we're initializing things at this point, and we should be fine, if that makes sense. That seems like a reasonable thing to do. I guess I don't know for sure, but it seems like a reasonable thing to do. So if we were going to allocate this here, we would pass the assets, and then we would need an arena. And again, we have an arena in here, but it's the collation arena at the moment. So again, this debug state kind of wants to make sure that the debug state is more of a real thing, right? And so I think what I'd also like to do is make it so that it doesn't really matter what order you call these functions in. I'd like to make sure that no matter what order you call them in, you can still make sure that this stuff kind of works properly. And so in order to do that, I'm going to use another little common convention that I often use, which is that what I'd like to do is every time you go to get the debug state, it'll just quickly check to see if it's initialized. If it's not initialized, it'll initialize it. That way, everyone who does this will always get the debug state, will always have the ability to do the initialization, right? So I want everyone to come through here, if that makes sense. I want everyone to always check all of the stuff that we might do. We'll look at this in a second. I'm just throwing everything up there, and we'll kind of then organize in a minute. And I want everyone to kind of go through there. So inside debug game frame end, that's a thing that actually doesn't use the global memory because it has the memory passed into it, right? And so what I might also say is like we could just double this up so that actually there's one that takes a void, and the one that takes a void, all that does is that just does a debug get state with the global memory, like so. But if you happen to know what the game memory is, then you can just call it directly. And that way, we can also do things like if we have more information about what the memory is, we don't have to count on the global being initialized, which might give us a little bit more flexibility depending on the circumstance, right? So yeah, in that situation, here we would just call debug get state, and then we would pass it the memory like so. And now we have a little bit more insurance there. Okay. So well, you know what? I guess there's some things in there, but before I go back to that, what I'd like to do is just make sure the initialization code works relatively well. So what I'd like to do here is say that we have a debug arena, and I'd like to kind of get that arena into more of a sort of the standard way that we've been doing things, where we kind of have a tiered access. So in here, I'd like to have the debug arena, something like that, and I'd like to initialize the arena like so that we use the whole thing for this debug arena, and then the collation arena can just be a sub-arena out of that, right? You remember we had the concept of these sub-arenas here, where I can just say, okay, I want to reserve some of the memory from it. I'm going to go ahead and say that, oops, this got to move out as well. There we go. So I want a collation arena, and I'm going to have some kind of a size to that, but it's going to be allocated out of the debug arena, right? It's going to have a size that we prescribe, which I don't know really what we want it to be, and I don't care what the alignment of it is, right? Although maybe, you know what, in this case for collation, I don't know that we would want the alignment to be 16, so maybe we want the alignment to be 4. 16 may be a little aggressive. So we've got this guy. We're doing the arena collation here, and how much do we want for that? I don't know. Maybe we just give that 32 megabytes of memory. I'm not sure. Again, I'm not sure what we want to do about collation in the long run. So for right now, we'll just leave it at that. Okay. So when we do the rest of our stuff here, that'll work. So then what I want to do is move this up here and say, okay, we've got our render debug group. Our debug render group. What we want to do is say, okay, if we're not initialized, then we need to also initialize our render group. Now we know that this is the first time we're doing anything, so we need to initialize it. We can say how many megabytes we want that to be. We can say that we want it to come out of the debug arena, right? And yeah, that's really all we need to do, I think. So now when we do this stuff, I don't really know. It kind of feels like this stuff wants to be kind of wrapped inside the debug code, It's kind of weird that it's sitting out here for no apparent reason. So I kind of feel like we want these to be just debug begins and ends. You know what I mean? We want this to just be like the debug render group. This stuff that's happening right here, I feel like should just kind of be wrapped up in the debug CPP, you know? That just seems like just the logical thing to do to me. I don't know how you guys feel about that, but that's kind of the way I feel about it, you know? And so debug reset, I think should probably just be, should include this stuff, right? So you just call it, and you don't have to check. You just call it, and this thing, you know, knows that this is all set up, right? I feel like that's just fine. I don't feel like anything weird. I don't think that really makes any sense to not do, right? So then, when we get to the end, this, where we do the debug overlay, let's just go ahead and put debug overlay. Let's put that in here. So debug overlay, this can just be a timed function, right, instead of a timed block. And then let's just make sure we actually do this stuff, you know, in here. So we'll just go ahead and make sure that stuff actually happens. That way we can just say, okay, debug overlay, and it does its thing. I don't know that there's any reason why we can't just do that, so I feel like that's what we will do. All right. Hopefully that all makes, again, I'm not doing any, I'm just consolidating things. Like I said, this week I want to do UI work, so I'm just trying to clean up how this is working now that we kind of have it all organized, so that I can make sure that there's nothing weird happening, right? Okay. Oh, so yeah, we gotta figure out how to get the assets in there reliably. That's a little harder. And to be fair, one of the things about the debug assets that's kind of annoying is really we don't necessarily want to have to use assets in the debug system, because if like the asset system is broken, it means that we wouldn't see our fonts at all. You know what I mean? Which is kind of a bummer. So oftentimes the way that you actually do this is you wouldn't have the assets be used in the debug system at all. What you do is you make a little thing that like packs up some font into the executable itself that you can just load out of a static array, right? And so, you know, that's something that probably would be nice to do. But in this particular case, I think we're going to struggle through it this way anyway, just because it's probably a lot of extra work to go ahead and do all that stuff for that purpose. But we'll think about it. Okay, so restart collation, debug identifier not found. That's true. That has not been found. I feel like this stuff is stuff that really we're going to be getting rid of soon anyway, because we want the frame processing to be more incremental. But for now, it should be okay. So if we're doing restart collation here, then we know that the current event array index is actually going to always be 0 because we just started. So we know that that's already 0. So we really don't need that particular piece of information for all intents and purposes, I should think. I say. I need to think this through a little more about exactly how I want to do some of this stuff. But for now, I think this is fine for restarting the collation. That's probably fine. And yeah, so we're just the assets that's a problem there. So for right now, I think I want to defer that because I want to think about that a little bit more. So what I want to do here is just go ahead and port the rest of this stuff. So debug state render group. That doesn't need to happen. Let's see. Assets, restart collation, render group, debug state render group. Oops. And same thing here. There we go. Last one. Well, not really. Transstate high priority queue. That is true. We do not have the high priority queue. So we would have to get past the high priority queue there. That is definitely the case. So let's see. Debug state, debug render group. All right, so I think we're all good there. So now we gotta think this through a little bit. So we need to be past some other things here. We need to be past what we need to actually accomplish that information. Now, although I guess I don't know, now that I think about it, let me take a look here. Game memory. So actually, we do have that information, right? That's just in the global game memory there. So we actually can just use that directly, because in here we know that we've got the debug state, and we know that we would have, right, the high priority queue information already set up. So if we want to, we can just do this, right, where we do handmade.h. Oops. We can say that we just kind of grab that out, you know, of this thing. I'll move this down here. So the high priority queue can be set pretty much any time. So when we do our initialization, we can just say, oh yeah, okay, the debug state high priority queue equals whatever the high priority queue was there, and now it knows, right? And then I think the only thing we would have to do is get past the draw buffer that we are compositing on top of. That's really just about it. So let's take a look at what draw buffer is defined as. Is it just an image? It's a loaded bitmap. So really all we have to do is say, okay, we've got the draw buffer here. So debug overlay needs to be given the thing that it's supposed to overlay on top of, or on top of which it is supposed to be overlaid. And now we just pass it in there. Right? So now we just have this issue of the assets, and I'm not sure what I'm not sure how I feel about this. I'm just not sure. It's a bit of a conundrum. It's conundromical in that sense. Again, because the only real reason that we have the assets is for the fonts. Although, to be fair, maybe the debug system wants to be able to draw like textures in like a little viewer so we can see what they look like or things like that. So I guess it's not that unusual that the debug system would want access to the asset system. But it does mean that we have this problem of we don't really know exactly when the debug state is going to be initialized. So what we could do, I suppose, is force the debug state initialization to happen at a known time when we know the assets are configured up. But that's a little, again, it's a little janky, especially in the cases where maybe we start to have situations where there could be, you know, threads involved. I don't know, but thinking it through a little more, I suppose everything goes into buffers for the debug system so far, and we could just assume that things generally are going to go into buffers because they have to be thread safe anyway. And so at that point, it's not such a big deal to say that things have to happen. So we could still leave this essentially the way it is. We could do something like this, where we say, okay, there's like a debug initialize call that has to happen, and you know, it does something like this. Like so. And when you do debug get state, actually what happens is it just asserts that nobody ever tries to do that when the debug thing has not been initialized yet. You know what I'm saying? So basically debug initialize just takes the game memory, and maybe that can actually just be the call that actually sets everything up in terms of the debug global memory as well. In fact, we could make it so that the initialized state kind of runs off of that. in some way? Let me think about this a little bit more. So if you take a look at handmade hero.cpp, the way this is working is that at the top of it, we assign the debug global memory like this. And so I feel like at that point, you could really just make it be that that's the debug initialize call, right? I assume. Although, well, if it's got to get past the assets, right? The assets don't get initialized till down here. So technically, this is the earliest that they could actually be initialized in that sense, right? Is after these happen. So I don't know. That's kind of a little bit tricky. But we could make it so that we call debug initialize here, right? Maybe I'll call this debug start and debug end or something as well, just for fun. There we go. And if I'm going to do that, I could just say, all right, debug start is actually going to be this guy right here. Right? Something like this. And it will be the one thing that doesn't go through this because it's allowed to be uninitialized, if that makes sense. We'll delete that. And so in debug start, and we got 20 minutes, right, because of the late start today. So we've got another 20 minutes to go, even though it says Q&A begins now. It is not true. So if we're in here, we know that we can get the assets now. We know that initialization would happen at a good time for us. We know that we can kind of set all of our stuff up. And that's kind of nice, right? So if we are to go that route, yeah, if we are to go that route, then I think we should be in good shape. And when we do our debug start, debug end, the weird thing about debug end is it's not really debug end frame. It's just the part where we draw. It's the sort of the debug drawing end. So it's a little bit of a misnomer there, but that's just the nature of debug code. It's kind of a little nasty how it integrates in because it's kind of trying to capture as much as possible. If that makes any sense. So yeah, so I think that would probably be okay. Let's take a look at where that gets us so far. Okay, so we've got debug start, debug end. That's all fine. In here, when we call debug start, this could also take the game memory. So that's not a big deal either. Although it doesn't really need it, I guess, because we know that the debug global memory has to be set every frame anyway due to the live code editing, so that's fine. This guy is all good. You just got to grab it out of there. Let's see, same thing here. And then restart collation just needs to be predefined so that it can be called up there to initialize things. And like I said, that's something that I think we want to kind of improve a little bit the way that works anyway. So debug start and debug end just need to get pre-declared because they replace these two guys. Here we go. Okay. And I think that's just about it. So hey, we're still drawing. We got the fonts working in debug and all that stuff seems to be fine. So let's see now if we can get our loop live code editing working. If I recompile this, now I'm totally fine. So that's great. We can just keep going with that now so that we don't have to worry. Loop live code editing and debug services will be nice and harmonious with each other, and that is a good thing, right? That's all nice and dandy. And in fact, I assume you could probably even just do this, and it doesn't even bat an eyelash. So that's all pretty great. That is what we want. That is happiness and goodness. So yeah, so I think that's all fine. Let's go ahead and keep going with that. Now that we've got those things kind of reorganized a little bit more, let's try and make something. Let's just try to get our UI story a little bit straighter, right? So again, just a little bit of baby step. What I'm going to do is I'm just going to make it so that the profile view can maybe like be resized or something, right? I just want those profile bars. I'm just going to play with that a little bit. So let's say, for example, that we would do something like rectangle 2, and we wanted to make like profile rect or something like that. So I'm just going to make a rectangle, and I'm going to say that the rectangle is supposed to go. That's where like the profiler stuff is supposed to be drawn. So if I do that, if I come into our debug end, you can see, and in fact, I guess we've got some residual code in here that we may want to, well, I guess we might want some stuff from it. That's why it's still there. So you can see when we do this drawing stuff, right, we have a bunch of information about how this is going to be drawn, and we've got some like scaling stuff and all that sort of thing in here. What we could do, presumably, at least I can't think of any reason why we can't do this, is we push an orthographic transform on, right? Like there's our orthographic transform. It seems to me like we could pretty easily just make that orthographic transform be something that actually happens kind of like in the middle of the actual code. So, you know, if I'm in here and I'm like rendering this stuff, you know, I could say that I'm just going to, before I draw this stuff, you know, I've got an orthographic transform that gets kind of stuffed on here, right? So in theory, I'm just gonna see what happens here. In theory, I could do something like this. Well, actually, let me just do it this way to make sure it works first. But I could just do something like this where I push an orthographic transform on, you know, and here is me just like setting up the exact same transform. So in theory, I should just get like exactly the same. What is it complaining about? Conversion from R32 to N32. I love how like Visual Studio doesn't even tell you which argument. Like they couldn't even figure out which argument it was that had the conversion, so you have to guess. It's like, thanks guys. From R32 to N32. So didn't we just copy this? What are you talking about? Where's the function? So it's int real. So what? Oh, so I should not have done that. That was a mistake. Oops. So these really, it's really the other way around. So oops. So in theory, if I run this, it should run, and it does, and that's good. But now I'm going to just see what happens if I just say, oh yeah, why don't you just make that be like half the height that it was or something, right? Oops, gotta put that here. Why does that take integers? That doesn't really make any sense. I feel like that's busted, in my opinion. Oh, and I guess I see why. So the orthographic thing, I probably just forgot how we implemented this. So pixel width, pixel height, and then meters to pixels, the scale is actually baked into here. So that makes sense. So really we don't need to do any of that. We can just do this, and I just make it half the size, like so. Right? Okay, so that makes that guy smaller, right? And in fact, I can presumably just make him as small as I want, right? Like if I want to make him even smaller, now he's even smaller, right? Because since the renderer like has everything going through a transform, it's really not a big deal to have that happen. Now, the problem that we will have, and you can actually already see it, is that we don't actually transform the mouse into that space at all. So we have the mouse position. We just use the mouse position directly to check for like hit testing and stuff like this. And that's not useful, right? That's not going to cut it. We need to like figure out where the mouse would be in the transform space. So that's another thing that we're going to have to watch out for. But at the moment, I'm not going to be too concerned about that. I'm just going to focus on sort of this other separate part. Okay, so transform-wise, we can pretty easily transform this guy by using the orthographic transform to change his shape as well. And we can also leave his shape the same in addition, like we can do something like this, leave his shape the same, but also control what his actual placement on the screen is, right? So I'm going to go ahead and do that one. We've got like the chart left, and we've got the chart bottom here somewhere, chart top, right? So if I want to have some way to move this around, I can just make it so that, like I said, I've got like a rectangle here or whatever that I've defined called profile rect. I could just make it so that the data actually comes from there. So, you know, somewhere I set the profile rect, min x, or I guess I could just do profile rect equals rect min max. And I can just set this to something, you know, whatever I actually want the min max to be. You know, maybe I want the thing to be 10f to 200, 200. So like a little 200 by 200 square up in the corner, or maybe it's a little bit further down, something like that. I can, if I want to, just get all of the parameters out of that for this particular thing, right? So how would I do that? I guess I would just go the chart top is going to be whatever this profile rect says it is. Oh, and I guess I shouldn't say 50, so if it's actually 50, 200, it's actually going to be down at the bottom corner. Always going from the top down. That's just an old school programmer problem. So the chart top, right, is just going to be whatever the profile rect max y is. That's just going to be the top. And then the left is going to be whatever the min x is, right? So that would start with that. Rect min max, no overloaded function. Right, got to put some v2s in here. Forgot about that. There we go. Yeah. Yeah. Okay, and so if we take a look at that, right, and again, it's actually like these. I always forget our coordinate system's from the center in this case. So 50, 50 is actually going to be like up 50 and over 50 from the center in theory, right? Pixels. So I'm not sure if that's exactly, yeah. So that's probably about right. It's hard to say. It looks like it's a little off. But yeah, that's basically the idea. And then for the scale, right, we could also say like, okay, whatever the scale is, our chart width of 1,000, we could just use whatever the width of this thing is, whatever the width of our profile rect is, to scale, but since this chart's already got the scaling built into it, right? Oops. We don't have a get width function on our rectangles? That's kind of crazy. Get min corner, match corner. Oh, it's get dim. So there's the width. And so now, right, like, yeah, the thing is super tiny, because now we've set the width to be only however much we specified in there, and that's all fine. But we also have the problem that we don't respect the height of this thing, right? So again, if we wanted to operate kind of in a box that we could control the size of, we would need to like shrink the width and stuff and the height of things in order to fit into the box. So that's another thing that we have to do. I do want to know, though, I'm a little bit confused. Is that really 200 pixels worth of width? It seems a little bit not so much. Oh, right, because it's actually only 150, because this is rect min max. Yeah, so you know how it is. Anyway, so Yeah, that all looks fine. So if we wanted to change how the height got interpreted, we know that we have a certain number of lanes, and we also know that we have a certain number of frames that we're going to draw. So if we just go ahead and backsolve for how many of those we want to have, right? If we just come up and do something like this, we now know what the max frame count is, and we know what the lane count is. So assuming that the max frame, we could do something like this, where we just go, okay, we need to know what the lane height is, right? What we could do is say, all right, the lane height, we're just going to assume that the lane height is 0. And then we're going to do, assuming that the max frame count is greater than 0 so that we won't divide by 0, we'll just say that the lane height is going to be whatever the max frame is times the lane count. Right? That's how many lanes we have to draw. And then we're just going to say that however big, that's how many total we have to draw. So however big that actually is going to be. Well, I guess we also have this spacing concern here, right? So we have lane height times lane count, and then we've got this sort of spacing that produces the bar height. We've got this sort of spacing here. So there's a constant of 4 that gets added in here, right? So we want to specify that as well. So we want to talk about basically like, bar spacing equals 4.0 or something. Bar spacing. So this is actually like bar plus spacing, like that. So this is plus bar spacing. What we want to do here is backsolve for bar height, right? Or rather, I should say backsolve for lane height, so we know how big the lanes are. So to do that, we know we have this many of them. We know that for every one, well, I guess we kind of need to do this in 2 stages. We know we have this many blocks, right? And we know we have the get dim of the profile rect. We know we have this much total space, right? That's the entire height of the chart. So if we divide that by max frame, now we know how big each block of bars could be. But we have to then say, okay, the bar height itself, we know there's spacing in between them, so we would need to subtract away, right, the bar spacing from that result, because each one of those bar blocks has this extra amount there. And then that total amount that we have left over, and there's there's a fence post thing we could do there because it's not 100% correct, but we can talk about that in a second. If we then divide that by how many lanes we want, that would give us what we're looking for the total lane height. Okay. So yeah. So now we're getting a little bit closer to where we want to be, but we kind of have some more work to do here. But point being, we're getting there slowly. So what I want to do now is I want to start debugging this and then also have a way that we can sort of test moving it around. What I'd like to do is I'd like to draw whatever the rectangle is. So this rectangle right here, I'd like to be able to do like a push rect outline on that. Or I guess I don't even really have to do a push rect outline. I'm just going to do a push rect first before we draw anything else. I'll do a push rect of this guy. So when we do this push rect, here's the render group. Let's go ahead and do push rect. So when we do push rect, I need to pass it to that group. I need to pass it the rectangle. I need to pass it the Z. And then I need to pass it a color. And what I'm going to do is I'm going to pass it just like essentially a sort of a black overlay, right? So there's our supposed rectangle. And this confirms what I thought before, which is that our rectangle is kind of busted. So I don't understand, like, our rectangle min-max, if that's actually correct, I guess, well, you know what? I guess it could be. Is 50 pixels only that many? All right, so I guess that is actually correct. That may actually be correct. So we're all good here. The only thing that's a little janky is we go outside of the rectangle because our current definition is we don't actually sort of stop anyone at the moment from, if you take more time than you're supposed to, we don't stop you from drawing outside the bounds, which I don't know that I necessarily even want to fix because that's kind of something I wanted to see there, but we could try to make that a little bit more prettier later on. So that's also totally reasonable. What? That is super weird. Oh, wow. So we have a bug. We have a total bug there. That's pretty interesting. You can see that we, when you click the button, when we do resetting, look at that. Check that out. Remember I was saying that you find problems in debug stuff? I just want to show you this. So when the left mouse button goes down, mouse button. When we do refresh collation, we had this giant spike happening in the frame thing, right? Oh, well, I guess it's not a bug. Now that I think about it, it's not even really a bug. That's just what would happen, right? So if you take a look at what happens here, when I click the left mouse button, it recollates all of those frames, right? Because that's kind of the way we have it set. And you can see it taking all this time to go recollate the frames, which pushes out the time when it does the render to one whole frame afterwards, basically, right? That's kind of cool. All right, so let's try to solve the one obvious bug that we do have here before I guess we're almost out of time. We're not drawing high enough, so I just need to kind of get my math in order here for the max frame count situation. Okay. So we have our max frame thing here. This is how many frames we're going to do. We have our lane count, I like that. So we get how the total width we have, and we know that we have this many frames that have to fit in there. So we find out how much. This is basically, this divide tells us how many frames, how many pixels per frame we have. We then subtract away the bar spacing from that because we know that we're going to put that much space in between them. So we only have the residual of that left, and then we divide by the lane count, and we get the lane height per lane out of that. Then we come back through here. We say, okay, we have the lane height times the lane count. That's how big each individual frames, but I guess we called that a bar for no real apparent reason. That's how big those should be, and that that looks pretty okay to me. I'm not sure why. Chart height bars plus spacing times debug state frame. That's actually wrong. I don't know if we actually ever use chart height anywhere. Do we? Yeah, we don't really ever use it anywhere. So it's not actually important, but that's actually wrong. This is actually max frame here, right? Because that's how many we're actually going to draw. That's the chart width, which we knew. That's the chart top, which we also knew. That's the scale, which only affects the left, right. So yeah, I'm not sure I understand exactly what it is. So I'm just going to go ahead and break this out and just take a look. So if we do get dim times max frame, like there, this is basically pixels per frame plus spacing. Then we have pixels per frame, which is that minus however much there is in between each bar. And then after we're done with that, we have the lane height itself, which is just the pixels per frame divided by the lane count. And I just want to go ahead and see, what happens there. This is bars plus spacing bar height plus bar spacing, and that all seems lane height times lane count. Yeah, I mean, that seems reasonable. All right, so let's go ahead and take a look. I'm just going to step in there and see if I can see what the problem is before we go to the Q&A, right? Let's go in here. Pixels plus spacing is 15. Pixels per frame. So what is debug state profile rect? So what does this say? It basically says that we've got, we should have 150 pixels to play with, right? And what's max frame? Max frame is 10. So 15 pixels per bar does sound right. We then subtract away the bar spacing and we get 11 pixels. We then divide by the lane count of 9, right? And we get 1.2 pixels per. Let's see what we do here. We then say the bar height is 11, which is correct. Bars plus spacing is 15, right? Which is correct. So the chart height total is 150. So that's actually computing it correctly. Are we drawing it wrong? So let's see how we draw it here. Bar spacing times, so that's the problem. We're just drawing it wrong. We changed the meaning of that and I didn't propagate it down. So it's really just bars plus spacing. Just needs to be propagated down. Like so. Bar spacing, is that not in there? Yeah. There we are. And so now we've got our stuff sort of sitting in a little window, which is cool. And yeah, I'm going to go ahead and go to the Q&A, if that makes sense. And take some questions here. Because we did plenty on this stream, and yeah, like I said, we're kind of in that mode where we're going to kind of, over the course of this week, drive the debug system into a state where it's more of an actual little kind of UI system that can sort of place things properly and not be quite so ad hoc, because we kind of know what we need now and the structure is there, so we can just kind of start placing things. So if you have any questions about what we were doing, go ahead and cue it. Miblo, I appreciate that there are more robust ways of implementing such things, but would it be practical to use the debug data to drive some of the game's visual effects, e.g. fire or more likely some otherworldly magical entity, or the display on an in-game computer? Maybe it could be sort of an Easter egg for those of us who know how the game's made. Well, the reason that I would be less inclined to do that is because it's going to take a big chunk of memory, and it takes a bunch of extra cycles and stuff to collect this information. So the idea would be that when you ship the game, it's compiled out. So presumably it won't actually be in there. But maybe, you know, maybe that's a bad decision. And maybe since this is a project that's about education, we should have a way for you to get at the debug code in the game to try and encourage people to play with it. So, you know, if that's the route we go, then yes, we certainly could tie it to something. Let's see. Elvin, there are magenta spikes in the debug graph that happen so fast we don't have time to click on them. How do we plan to catch those? Having the ability to step frame by frame could be useful. Another idea is to have the debug text left off at the last direct position we hovered. Well, don't forget, we can always pause it. And although we only see a few frames here, we actually have 64 of them. So what we're going to be doing with this debug UI is we'll be able to just kind of grab this and scroll back to the one that was a spike. So anytime we see that spike, we'll be able to just go like that and grab it, right? Even if it went off, because we've got a pretty big back buffer. And we can always make those back buffers arbitrarily bigger. On a machine that has, you know, a ton of memory, because like if your dev machine has like 32 gigs of memory because it's like some fancy dev machine or whatever, you can just dedicate like, you know, 24 gigabytes to a debug back buffer, and you could store all the events from every frame for the entire game in there if you wanted, and scroll back as far as you wanted. So there's no like limits on that. We can have a party. Any other cues? No more cues? If there's no more cues, there's no more cues. All right, well, no more cues. We will wrap it up. Oops. Okay, thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along with the source code at home, you can always pre-order Handmade Hero, the game, on handmadehero.org, and it comes with the source code, which I update every night, so you can always stay up to date with what we're coding and play around with source code at home, so that you can do your own experiments and learn things. We also have a forum site you can go to if you want to ask questions or if you want to look at an annotated episode guide maintained by the community. We have a Patreon page if you want to support the video series. You can subscribe to that. We also have a tweet bot which will tweet the schedule, so you can always make sure you're catching the stream live if you want to be. You'll know when it is up. So definitely check those out if you're interested. I will be back here tomorrow, 5 p.m. Pacific Daylight Time. For those of you interested in seeing the debug system become something more UI friendly, that is what we will be doing this week, and so it should be pretty fun. So tomorrow we'll kind of get some little kind of windowing stuff happening in there, and we can go from there. So hopefully I'll see you back here for that. Until then, have fun programming, and I'll see you guys on the internet. Take it easy, everyone.